Hey guys, we're back. This is video number 2 on the review packet. So we're going to start off with station number 4 of analyzing the trig graphs. Ms. Martinez wants to say what's up.
Hi.
Yeah. So what you're gonna need for these graphs is I told you that you're not gonna have to memorize how to make these graphs because you're gonna have these if you're gonna need to use them on a test, but you should know the graph of sine and cosine by heart, but you will have your graphs for the exam. When it comes to analyzing part of the test. So you have 6 graphs. You know, y is equal to sine, y is equal to cosine, y is equal to tangent, secant, cosecant, and cotangent. So using our graphs, we're going to identify every one of the graphs that applies to these situations. So let's look at the first situation. Determine the graphs which have 2 roots on the interval 0 to 2 pi. So I'm going to look at my graphs. Has 2 roots on the interval from 0 to 2 pi. So this is our graph of y is equal to cosine, 0 to 2 pi. Do I have 2 roots? 1, 2. Yes. So y is equal to cosine works. What about y is equal to secant of x? Do we have any roots? No. Y is equal to secant of x does not work. So we're going to write first, we got cosine of x. Let's look at the other graphs. We have y is equal to the sine of x. Do we have 2 roots from 0 to 2 pi inclusive? Yes, we actually have 3 roots from 0 to 2 pi inclusive. We have 1, 2, and the third root at 2 pi. So that gives you yes for, well, so what we said that y is equal to the sine of x has 3 roots, right? The question asks us which of the graphs has 2 roots. It doesn't say it has at least 2 roots. So just be careful and make sure that you're reading it properly. We said y is equal to the sine of x has 3 roots, not 2. Awesome. So y is equal to the cosine of x. As you can see, or cosecant of x has no roots. So y is equal to the tangent of x. Does it have 2 roots from 0 to 2 pi? 1 right there at 0, and again at pi, and then again at 2 pi. So how many roots does the function y is equal to tangent have? 3 from 0 to 2 pi. So does that apply for number 1? No. What about y is equal to the cotangent of x? How many roots do we have? From 0 to 2 pi, you have 1, 2. So the y is equal to cotangent of x. Yes, that function does apply. So what you're going to do is you're going to answer the rest of the questions using those 6 graphs that you have. Those 6 graphs are extremely important in order to be able to answer the questions on analyzing those graphs. I'm not going to expect you to have to be able to draw these graphs. All you're going to have to be able to do is tell me, just like we did in class before break got out, is tell me what do you know and which graphs apply to these certain conditions. Cool. So, moving on to section number 5. So section number 5. Top, it's just a review for a general triangle, not necessarily a right triangle. We know that these general rules and these trig laws apply. We know that whenever we have an angle and its corresponding side, we can use the law of sines in order to find the other side or the other angle, given that we have that one other piece of information. So as you see, when it tells you that the law of sines, you need an angle and the length of the opposite side. Basically an angle and its corresponding side. So if I had angle C and side C, I could use the law of sines if I had angle A. if I had angle A, so if I had angle C is 35 degrees, if I had side C is 20, angle A, let's just say it was 45 degrees, right? So if I had these values, I have an angle, its corresponding side, I have another angle, I can use the law of sines to figure out the length of A. How do I do that? Well, I say the sine of angle C divided by C is equal to the sine of angle A divided by A. We know that we use the law of sines and the law of cosines whenever we don't have right triangles. So we don't have right triangles, that's whenever we apply the law of sines and law of cosines. So sine of C, let's just go ahead and evaluate that, is sine of 20 divided by, the sine of the angle, so the sine of angle C, the sine of 35 degrees, divided by 20 is going to equal the sine of angle A, sine of 45 degrees, divided by A. How do I solve for A? Multiply by A on both sides. What am I left with? A times the sine of 35 degrees divided by 20 is equal to the sine of 45 degrees. Now what do? I still have to multiply by 20 on both sides. So multiply by 20. This should all be reviewed as we've covered it for the last 3 days. A times the sine of 35 degrees is equal to 20 times the sine of 45 degrees. How do I solve for A? Just divide by sine of 35. So A is equal to whatever you get when you calculate this box. So that was just an example of when you use the law of sines. So the law of cosines, you know, well, I'll show you when we use the law of cosines with the same example. So the law of cosines, it says that you need all 3 sides, or you need 2 sides and the included angle. Remember from class we said that if you have 2 sides that are connected by a certain angle, the angle that connects both of them, or the angle in between those 2 sides, is the included angle. It's like the slice of cheese and a bread in a sandwich. You have to have both pieces of bread on the outside and a slice of cheese in the middle in order to make a sandwich. So if you have either the 2 sides and if you have the 2 sides connected by the included angle, or if you have all 3 sides, that is the time when you can use the law of cosines. So you need all 3 sides, or you need 2 sides and the included angle. So there are 3 different ways you can see this. Those 3 formulas are on your worksheet. But the easiest thing to think, the easiest way to think through it is that, okay, well, whatever you're solving for, if you're solving for a side, it has to be on this side. It has to be on this side of the equation, right? It could be A, B, or C, any letter that you can think of, right? So if we're going to express it based on this triangle, well, the law of sines tells us that if I was looking for side C, right, and I had angle C is equal to 25 degrees, if I had B is equal to 20 and A is equal to 40, if I have these numbers and I'm looking for side C because I have 2 sides and an included angle, in order to find that last side, what I have to do is use the law of cosines. So I'm looking for the side that's opposite of my included angle. That side, it could be any of these letters. Let's just, it's letter C, so C squared is what I'm looking for, is equal to A squared plus B squared. This is both of the sides, so I'm going to go ahead and plug those in. 40 squared plus 20 squared minus 2 times both of those terms. Both of those terms that you just squared, we're going to multiply that by 2. So 2 times 40 times 20 times the cosine of whatever you're trying to find, or whatever you're solving for, well, whatever you set everything equal to. So you set everything equal to C, so that's angle C. So the cosine of angle C, which is the cosine of 25 degrees. So now what do? As we said in class, evaluate this first. Make sure you evaluate this first before you take the square root. Because once you take the square root, it's too easy to make mistakes in your calculator. So just go ahead and evaluate these, add them together, subtract them, and then multiply this entire function together, round to 3 decimal places, only at the very end. So you're going to continue to express as many decimal places as you can until the very end. So then you're going to get C is equal to the square root of whatever you get whenever you solve this out. And that'll give you your answer for side C. But if you had, so just to push this a little bit more, let's just say we changed our problem and we didn't have our angle C, yet we had all 3 sides. And this was 15, right? Well, if I was looking for angle C and I already knew my side that was opposite of that angle, then I'm going to say C is equal to a squared plus b squared minus 2ab times the cosine of whatever angle that was opposite of the side that I already have. So in this case, C is the letter that's opposite of our angle. So C is what we're going to set our entire equation equal to. If you need to rewind the video to repeat that, go ahead and do that. So that's whenever we said C, which is 15 squared, is equal to 40 squared plus 20 squared minus 2 times 40 times 20 times the cosine of our angle C. Now we got to solve for angle C. What do? Well, 15 squared minus 40 squared minus 20 squared. All I'm doing is algebra. I'm moving these over to the other side. To go to negative 2 times 40 times 20 times the cosine of C. Alright? How do I solve for the cosine of C? I divide by negative 2 times 40 times 20. Divide the entire side by negative 2 times 40 times 20. Then I get cosine of C is equal to 15 squared minus 40 squared minus 20 squared over negative 2 times 40 times 20. How do I get my angle by itself? Well, I have my function. To undo the function, I have to take the inverse of that same function every single time. If you're like, what? Well, the only way that we undo the function or get rid of our function is by taking its inverse. So we know that inverse undoes the work of our function, so if we do the inverse of our function, they both cancel out. So the inverse cosine of everything that we calculated on that side would give us angle C. So C is equal to whatever you get whenever you plug in the inverse cosine of 15 squared minus 40 squared minus 20 squared all over negative 2 times 40 times 20. And that will be how you use the law of cosines in both ways. That was just a really good review. If you have any questions, definitely practice, practice, and practice. And you know you can call me. So, cool. Let's move on to one example problem. I think I already did enough examples. So, alright, continue on the next video. Deuces.